Hey y'all, welcome to our fifth and final day of our Unit 4 review. And what's kind of interesting about today is that we have typically been reviewing topics that we learned in Unit 4, but this is actually the first topic that we have not learned. So this is our first lesson where this should not be familiar. You should not know anything about feedback loops except for our first kind of intro into this topic, which is homeostasis. But this is something that I never got to taught y'all, and I was not going to teach y'all. I was just going to move on to our next unit. So I'm going to take this opportunity to make sure that you're taught all the TEKS for biology. So again, today, this is our last day of our Unit 4 review. Starting next Monday, we are going to start our new unit, which is going to be very exciting. Ecology is a lot of fun, and it's very applicable to the world that you see around you. But please don't forget that you do have a quiz that will be posted tomorrow. It's going to be your second mastery quiz. And I will try to have those grades back to you by Monday. Okay, so we're going to start off with talking about this concept we've talked about before called homeostasis. And immediately when you hear that word homeostasis in your mind, you should be saying balance. But what kind of balance are we talking about? What's being balanced? I want you to think about this picture. This is a body on a scale almost. Homeostasis is the regulation and maintenance of your body's internal environment. Okay, and we're going to talk about what that internal environment means. But I give you one example down here. Your internal environment could mean your inside temperature, which is kind of my example. It says when Coach Gossett gets hot, he's going to begin sweating to cool back down. Coach Gossett, if you're watching this, please don't kill me. Our bodies maintain to respond to the environment by homeostasis. Okay, so again, that internal environment could be your temperature. It could even be your blood sugar level. Your blood sugar level is going to be either high or low depending on the last time that you've eaten. It could be your heart rate. I'm just going to put HR, heart rate. It could be a lot of different things. Okay, so we're going to go through a couple examples. We have these different control systems that are going to help maintain homeostasis. So if you remember, we have sensors all around our body that are going to gather and interpret this information. So these sensors are going to be part of our nervous system. And also our brain. We have a control center that's going to receive this data and send messages. And this is going to be our hypothalamus. We're going to talk about this a little bit later. Hypothalamus. Okay, then we're also going to have a communication system that's going to deliver messages to target organs, and those targets are going to respond to the change. So these are actually, this communication system delivering the messages, these messages are going to be hormones, and so we're going to have two systems. We're going to have the endocrine system that's going to produce those hormones, and we're also going to have the circulatory system deliver those. So we've got lots of different systems that are helping our topic, which is feedback loops. Over here we have an example of, this is a piece of skin. This looks like a cross-section of your skin. We've got your pore, your sweat gland, and let's say that you've got water on your skin and it's really cold. What's going to happen is you're going to have this muscle that's going to pull, and it's going to pull your hair follicle back, and your hair is going to stick straight up and down, and that's going to cause goosebumps. Okay, so that's an example of a feedback loop that we're going to talk about. So the first type, we have positive and negative feedback loops. We're going to talk about negative feedback loops. Okay, negative feedback loops control systems that counteract any change in the body and move conditions either above or below that certain point. So they don't want that point to stay the same. This is going to keep your internal environment stable. Again, we're talking about homeostasis, and it's going to shut off the original stimulus. So that's why we consider it negative. So the way that I like to think about this is I like to think about a scale. Ooh, that was a terrible straight line. Okay, let's say we've got a scale, okay? And on this side of the scale, we have some sort of variable, okay? Variable. Now, in order to keep the scale balanced, in order to maintain that homeostasis, we have to have a counter response over here as well. So we've got to have something in response to this variable, okay? So they are interacting, but they're keeping it balanced. You notice that our scale is still even, okay? So basically it's going to shut off the original stimulus. So we're going to go through an example of this. So let's say our starting situation has something high, really, really high up here, okay? That means our negative feedback loop is going to counteract that and bring it down low. Now it's too low. We need to get it back high, and it's going to keep happening until we reach this word equilibrium, which means balance. And again, that's the whole point. We're trying to reach homeostasis. So negative feedback loops are going to help us reach homeostasis. Again, negative feedback loops help reach homeostasis. So here we have an example of what's actually happening in your body. Now this diagram looks complicated, but it's really not, okay? So first I'm going to do yellow because we were just in yellow. This is our hypothalamic set point in the middle. So we've got a normal body temperature, okay? So this is what we are trying to achieve. This is our homeostasis point, okay? We want our body temperature to be at this point. But let's say that our body temperature rises. Maybe we go exercising, okay? This is our variable. Our body temperature just rose, okay? Now our body has to respond. So we need to bring it back down, if y'all remember. So our body is actually going to respond. Your brain realizes that your body temperature has risen, that point in the hypothalamus, okay? And actually what it does is it signals your blood vessels to dilate and sweat glands to secrete. So what actually happens is your blood vessels become smaller and you start to sweat. Those two things actually allow heat to be lost. And what happens in response is your body temperature goes back down. So this is these are our counter responses. That lead to your body going back down. Now, if you look at the opposite's the same. Let's say our body temperature drops. I don't know what just happened to my picture. Let's say our body temperature, again, drops below normal. Now, we've got these two counteractive responses, okay? Your brain can either signal to your blood vessels to constrict, become smaller, and your sweat glands to remain inactive so you don't sweat at all, you don't lose any heat, so body heat is conserved, or your body temperature continues to drop, the nervous system signals muscles to contract involuntarily, which is actually shivering, and your muscle activity is going to generate body heat. All of those things, our body temperature has dropped, all of those things are going to help our body temperature rise. So again, these are our counteracting responses. Okay, and we are doing the opposite of whatever our variable was. We do have two different types of nervous systems in our body. We have the sympathetic and the parasympathetic nervous system. Our sympathetic nervous system, if you've ever heard of fight or flight response, that's the thing that's going to pump adrenaline through your body, and so you're going to have an immediate physical, usually, response that's going to be quick. And your parasympathetic nervous system is going to help calm and return you to equilibrium. So these, if you notice, they act in tandem, so they work together to bring you back to where we want to be, which is the center point. Now we have the opposite system. Okay, now we're going to talk about these positive feedback loops, and we're going to look at some examples. The positive feedback loop is still feedback. We're still sending out a hormone, and it's going to elicit a response. But this is talking about a control system that uses information from sensors to increase the rate of change away from those set points. So you know how our body likes to be equilibrium? Well, positive feedback, it's raising that. It's telling us we're in a situation where we don't need to be at equilibrium. We need to be doing something a lot faster, a lot quicker than we normally would do. So this is not, positive feedback does not equal homeostasis. And we're going to see an example of that in just a second. It's not common, and it's only used when rapid change is needed, and it turns on a stimulus. So what that means is we're not going to have a balanced little homeostasis balance here. We're going to have a tipped balance, okay? And if you remember, we have a variable, and that's something that's happening in our body, and it is causing homeostasis to not be an occurrence. But instead of having that counter response like we had over here, we're not going to have that. I'm going to erase that. we had a counter response for our negative feedback loop, but instead we're actually going to have plus signs over here. And these are going to be my response. And they're going to increase and continue whatever's happening to happen. So it's going to continue supporting, and these plus signs are going to keep supporting whatever is happening, whatever the variable is resulting in. Oh my gosh, that was a terrible plus sign. They're going to keep happening whatever's happening. It's going to keep supporting whatever this variable is. Okay, so that's a little bit different. Again, it's turning something on and it's keeping it on. And it's not common. Remember that? It's not common. It only happens in specific situations. So we're going to talk about some situations in which it happens. So again, we normally would want to be in equilibrium right here in the middle, but positive feedback does not, that's a does not sign, does not equal equilibrium, and thus it does not equal homeostasis. Homeostasis, I always spell that wrong. So what's either going to happen is this positive feedback is going to have something that's above the equilibrium or below the equilibrium happen. Again, it's going to have these extremes happen, but there's going to be absolutely no equilibrium. So an example of this is if you're talking into a microphone and, you know, a crowd can't hear you. Let's say that we're in the lunchroom and Mr. Pena is, you know, talking at y'all through the microphone and telling y'all to pick up your trash, and he's kind of telling funny jokes like he normally does during lunch, and y'all can't hear you, and then he plugs in an amplifier, another speaker, and that's going to basically increase his volume, right? His volume's only going to go up. It's not going to decrease. It's not going to counteract it. That's going to have an explosion of sound. Okay, that's an example of a positive feedback loop. A negative feedback loop would be if Mr. Pena was talking on the microphone and somebody went up and unplugged it and they stopped it. So that would be an example of a negative feedback loop. But again, a positive feedback loop is we're going to have that sound just continue going up. We're going to add more speakers. We're going to amplify it. And again, this isn't typically common. Our common feedback loops are going to be negative in our body that help maintain homeostasis. But we're going to have certain examples. This example is about childbirth, where we need a positive feedback to happen in order to accomplish a goal. And so for this example, we're trying to have a baby, right? So I'm going to kind of annotate this graphic. The first one is when childbirth is signaled, the first thing that happens is the head of the fetus pushes against the cervix. Okay, so our variable is that we are about to have childbirth. Okay? Now, we don't want to counteract this. We don't want to keep the baby in your mom's stomach for more than 9 months. We need to get it out, right? So one response is the nerve impulses from the cervix are actually transmitted to the brain. Okay, so that's a positive response. Okay, that brain is going to signal to the pituitary gland, which I know that y'all don't know what that is. It's part of the endocrine system, and it's going to secrete oxytocin. So what's happening is the endocrine system is actually secreting a hormone here. But again, this is continuing. This is supporting this variable of childbirth. So it's another positive thing, okay? Oxytocin is then carried to the bloodstream in the uterus. So again, the circulatory system is going to carry that hormone where it needs to go. Another positive thing. And oxytocin stimulates the uterine to actually contract and push the fetus towards the cervix. So when we're talking about contractions, we're talking about the muscular system is actually signaled by the hormone. And in this case, the hormone was oxytocin. And again, that's another positive thing. So we've just got, oh my gosh, that positive sign is like the worst thing. Y'all can comment on my positive signs in the comments. That was the worst thing ever. These are all positive things. So remember, our feedback loop, we are going to be heavily unbalanced here. We've got our variable, and then we've got all of these positive things over here continuing to support the unbalance of childbirth. Okay, so we're continuing to unbalance this homeostasis scale until childbirth happens, and then all of this will stop. Okay? Okay, so we are going to go through a couple examples in just a second. But what I would always suggest doing is when you're given a scenario or even a word problem, to box the different things that are happening. Okay, so if we are thinking about a positive, or let's start with negative. If we're thinking about a negative feedback loop, I'm just going to put FL, feedback loop, and you box a certain scenario. Let's say it's this thing happens and it's A, okay? I want you to box the next thing that's going to happen. Okay, the next thing that's going to happen is going to be B, and let's say there's another thing that happens over here that's C, okay? I want you to draw an arrow from A to B and decide, is B like supporting what's happening in A? Okay, and if it is, you're going to put like a plus sign. So for example, for negative feedback loop, this first one, this response still might be happening even with the response of B. It still might be happening. But let's say C is actually going to be where it counteracts that response, and it's going to down-regulate or do the opposite, and it's going to result in the opposite. And then we might have another, and then it's going to lead back to A, which either could be a negative or a plus sign, and it could continue, okay? So this might be what a negative feedback loop is going to look like. And at the end, this is a negative feedback loop, okay? Now our positive feedback loop, guess what? It's going to have a bunch of positives, okay? So let's say the first thing is going to be, we can start with A again. And then we have another thing that happens in response to that. B is going to continue to support A. And guess what? If we have C, C is also going to continue to support A. And it's, let's say we have another one, even D. D is continuing to support A. So it's going to be constant plus signs. So if you only have plus signs, you know it's going to be positive. But if you have these negative signs that are going to result in the opposite thing happening, you know that that's going to be a negative feedback loop. So let's go through an example. So here we're going to try and figure out if this is a negative or a positive feedback loop. So the first thing that I see happening is I've got these pictures, okay, and it kind of looks a little weird, but we've got to figure out where it's starting. So holding breath, CO2 levels rise, control system forces exhale, CO2 levels return to normal. So this is in response to me holding my breath, okay? I'm holding my breath, and the next thing is my CO2 levels are going to rise. So I might do an up arrow. My CO2 levels are going to increase. The next thing that happens is the control system is going to force me to exhale. Okay, my CO2 levels, whew, that was loud. My CO2 levels still might be pretty high. Okay, so if I draw an arrow, this still might be pretty high. Okay, but now my third response, this might be C, my CO2 levels have decreased. Okay, so this actually resulted in a negative response. And let's say if I hold my breath again, it's going to happen all over again. Okay, but because I have this negative here, because I tried to balance it out, we know this is going to be a negative feedback loop. So if you also thought that, pat yourself on the back because you got it right. Okay, this is going to be a negative one. Now, the next one, I'm going to give you all a couple seconds to decide for yourself. This one is a little tricky. Okay, so let's do it together, but I'm going to give you all time to think about what is the result. So I'm going to kind of draw it over here, if that's okay. So the first thing that happens is torn blood vessels, okay? So that basically means someone got a cut, okay, and their blood vessels have been torn on a cellular level, okay? And that actually is going to release clotting factors, okay? So this is going to be release clotting factors. Okay, so basically, I'm bleeding, and I'm going to release these clotting factors, okay? The next thing that happens is growth hormones are going to stimulate cell division. So if I'm releasing clotting factors, basically what's happening is my cells are making more cells. They're making these clots, okay? And if I am going to increase cell division, I'm going to make more cells that are just going to keep clotting, okay? So this cut, I'm bleeding, it's positive. Releasing clotting factors, still positive. And if I increase my cell division, I'm just creating more cells that are going to continue to clot. And eventually, I'll have so much clotting that the cut will actually stop bleeding. Okay, so that's going to complete our loop. So if you see only positives here, we know that this is a positive feedback loop. And you might think like, Miss Lynn, what are you talking about? Like, eventually it's going to stop bleeding. So if you have a cut that's bleeding and it stops bleeding, isn't that the opposite thing? Well, you've got to think about the action that's happening on a cellular level. Okay, we cut ourselves. What's happening is initially the first response is cells are going to start clotting, creating more cells and clotting that cut. And what's happening here, the feedback loop that it's telling you, is that we're actually stimulating cell division. We're actually making more cells that are going to clot. So it's asking you specifically about cell division and what's happening on the cellular level that's going to help clot that cut. Okay, but that would be an example of a positive feedback loop. Now, this isn't going to happen all the time, right? You're only going to have a positive feedback loop, increase clotting in your cells when you have a cut. You don't want your blood vessels to clot normally, because then they could actually block the blood vessel, which can cause heart attacks or many other not necessarily good consequences in your body. The last example that we're going to go through is your blood sugar levels, which is kind of important. When you eat a meal, your blood sugar levels is going to change. So let's say that you just had a big piece of cake. Cake, because it's your birthday and you're celebrating at home in your quarantine. You had a big piece of cake. What's going to happen to your blood sugar levels? You're in this scenario up here. You just had a big piece of cake. You've got a lot of sugar, lots of sugar in your blood, okay? The initial response, you got to follow the arrows. We're here. We're going to go down here. Okay, this is going to be what we're going to do. This is the next response that happens. Your pancreas is going to get a signal from your hypothalamus that is going to tell your body to release insulin. Okay, so insulin is our hormone. Ooh, you can't even see it now. Insulin is our hormone, and it's going to lower your blood sugar. So this action, your blood sugar was really high. After this happens, what's going to happen? Your blood sugar is now low. Okay? Now, if your blood sugar is too low, then you're going to have another response happen. Your liver, instead, when you want it to go down, your pancreas is going to play a role. When you want it to go up, your liver plays the role. So your liver is going to release a different hormone called glucagon. Okay? Glucagon is going to counteract that. It's going to raise the blood sugar. So now we have the opposite again. Now it's increasing. So we've got a positive and a negative. Well, we have a negative, so we automatically know it's going to be a negative feedback loop. Okay? I want y'all to be able to explain to me how one of these feedback loops, what it is, and how it's going to work, and a short answer that's going to be on your quiz on Friday. Otherwise, please complete the worksheet that is attached to this slide. It's going to walk you through a bunch of different multiple choice word problems and how they might be worded. And if you have any questions on that, please come to office hours every single day from 1:30 to 2:30. Quickly, let's brainstorm different scenarios in which we could talk about these different things. So what are some body processes that your body might use a feedback mechanism for? We talked about one in the beginning. We talked about body temperature. That's one. If your body temperature is too high or too low, your body's going to respond. I'm going to attach a video link that you should go watch. You should go watch the video and that video will be linked to this this lesson. It's called Homeostasis, Negative and Positive Feedback Loops, Thermoregulation, and Lactation. It walks through two really good examples and shows you a diagram as it goes through those. Some other forms, what can you think of? What about when you haven't eaten in a while? Okay, hunger is a big one. When your blood sugar level's low, you will actually feel hunger. Your stomach will growl and it'll tell you that you're hungry. The opposite, if you're thirsty, it will also tell you you will feel thirsty. We talked about blood sugar level. Or even blood pressure. How hard your heart is working. We want your blood pressure in a specific zone. And even sleep rhythms. Okay, sleep rhythms can be controlled through feedback loops as well, which is kind of cool. I have a quick little review. So you want to try and answer these on your own, but I'm going to go through them relatively quickly. So if you want to pause the video before I write them down, write the answers down, you can. But these processes are controlled by, the answer for this blank is going to be like specific body systems, okay? So they are actually controlled by the endocrine, because the endocrine system is going to release those different hormones. And the nervous system. Now there's others, the circulatory, musculatory, they play a role too, but these are the two main ones, endocrine and nervous system, okay? The whole point of a feedback loop or a feedback mechanism is to bring you back into what? What is our body trying to always stay in? If you said balance or homeostasis in your mind or to your computer, you were correct. Pat yourself on the back. We want to get back to homeostasis. Okay, the next one says if something in your body goes blank too much, like your body temperature, feedback loops are going to bring it back blank. Okay, this has two answers. If something in your body goes too up, your feedback mechanism is going to bring it back down. And again, this is an example of a negative feedback loop. And if something in your body goes down too much, like water level, feedback mechanisms are going to bring it back up. Now, these are both negative feedback loops. Don't be fooled. There are certain scenarios where we want a positive feedback loop to keep the upregulation of whatever it's causing, but that's typically not what our body sustains at. Really quickly, so you actually can see where it is, the part of the brain responsible for regulating all of these key processes that sends all those signals and maintains homeostasis is this key player, hypothalamus. He is the MVP of your body. He lives right here in the center of your brain, and he's relatively small, but he sends all those hormone signals to make sure your body is properly functioning. And that's it for today. Please join me for Zoom office hours if you have